Okay, so Monday, the 27th of July, 4:25 p.m. in the afternoon. So go ahead and tell us what you're doing and what the problems are.
Okay. So I have built I have built the set model, the set model for floor 12 and 13 is being put together, and
Floors, 12th and 13th floors.
12th and 13th floors, right? And from now, so far I have only used self-weight loading, and I've used 2 different meshing techniques to model these 2 floors being put together, and the results I got are not quite different, but different.
And let's talk about what those meshing techniques are. Are those in the columns only, or are they in the beams, or where are those meshing techniques different?
So I meshed all. So for this one, I didn't mesh any free members.
Any what?
Any beam members.
Only the columns.
No, not even no, none. I didn't mesh any.
What does that mean? It means that you.
I only meshed the area, the concrete slabs.
All right.
And the deflection.
Hang on. How can you do that? Because anytime you have a cross grid on the slab, you have to connect it to the beam. You have to have a node there at that beam point. Whether you use a link or whatever you use, you still got to have a point. And so if you didn't have a point there in your beam, you're going to have an error. Where it crosses the beams and girders. You've got to have a node.
Where the beams
Connect the slab.
Yeah, where the beams connect, there's a node.
Okay.
And the slabs are connected to these nodes.
Okay, so you do have them meshed to match up to the slab meshing. Okay.
So that's why the deflection is very small.
Okay.
Otherwise, the deflection would be huge.
No, I understand. Okay, go ahead.
And the other one, I meshed the beams, the girders, and the columns, and the slabs. So the slab meshing for these 2 are exactly the same. And the difference is the first one I didn't mesh any beam elements. This one I meshed all the beam elements. And
so listen, you're getting some different results.
Right.
We don't know where the problem is. So why don't you go and create another model?
Okay.
And take the model where you don't have all this meshing going on and create a duplicate of what you've done for your columns only. In other words, let's progressively work towards where you are with this one.
Okay.
So add the nodes to the columns only.
Okay.
And leave the discretion.
Okay.
The same.
Okay.
As what you've got before you refined it. Okay.
Okay.
Let's see what that answer gives us. Okay. What happens to that?
Okay.
So if that matches up with either one of them, then that tells us, okay, an indication that the 2 meshes are giving us the same results. Okay? At that point. Okay. All right? Then I would progressively add refinement to the beams, but don't go and copy it over. In other words, do that again to see if there's any change going on with respect to that. In other words, we're going to take this piece by piece until we get back to where you are with this refined mesh to find out what the problem really is. Okay?
Okay.
In the meantime, Fong, you're going to check his results as well. Okay?
Yes.
To make sure that when we're done, we know that this mesh and this model makes sense for these 2 floors.
Okay.
All right? Are you with me?
Yep.
All right. So let's progressively work towards starting where we are without the refined mesh, and let's refine the columns only.
Okay.
All right?
Yeah.
That should not change anything.
Okay. Yeah.
And if it does, we know, something's going on here.
Okay.
All right. But before you even do that, I want you to sum up the reactions, sum up all the dead load, and see if the reactions add up to the total acting on. In other words, there's got to be an equilibrium, right?
Right.
And if you get 2 different values from the 2 different models, you know the loading is off. It's not the model necessarily.
Right.
But it's the loads, okay? So we first of all got to check the loading condition.
Right.
Make sure. If the error is in the loading, you're done. You begin to fix that problem, right?
Yes.
Right.
Yes.
So then you don't have to do all this other. But if that leads to the same answer, but different results, then we've got more work to do.
Right.
All right? You with me?
Yep.
All right. Okay.
Yeah.
What about you?
Yeah, Dr. Hulsey, I already defined the cross section, and what I'm doing today is I assign the cross section into the model, and after that I will make the beam right direction, and apply the load and compare with the sub 2000 model. Yeah.
So how soon could you compare your gravity results with his?
I think this Friday, yeah, I will get the load result.
Not
yeah.
before then, right?
Yes, I think so. Yeah, I need to. Today I will assign the cross section, and tomorrow I will make the direction so they offset at the same, offset the beam, and then I will get the connection, define the connection, then run, check there has nothing become wrong, and then apply the load. Yeah.
So I'm a little worried if there's is there a chance that you can make errors in this? I mean, how do we ensure that we don't have any errors in your model? Is that something Steve can check for you, or what should we do to not be in this mess of having errors in our computer programming models?
Yeah.
Well, I'll try to get access to the supercomputer center and try to learn how to use Abacus.
I understand that, but I mean at the same time, I'm concerned about your SAP models as well. I mean, we're taking every step that we can think of to make sure that we know for sure
Yeah.
that the values are correct. So, for example, we know that the model that you've got there with you in your AutoCAD is correct. We've checked that, right?
Yes.
Yep.
That's our beginning spot.
Yeah.
What we don't know, I mean, where's our error possibly that can be coming to play in your computer models? It's got to be a mesh refinement issue, or it's got to be a load issue, or it's got to be some node that's not connecting to some other node. It's pretty simple, really. So at the end of the day, that's what we got to get checked. Make sure that, because all the other stuff is where they need to be, right?
Yes, I totally agree. I think so. For we use different software, but the method we combine the beam and connection are same.
Yeah.
So our result should be same. So our result difference should be below 5%. So we should have same displacement, and if we check in dynamic field, we should have same mode shape or natural frequency.
Yep.
So if our displacement and stress and natural mode shape is same, so it means we are just use same different software make same model, because our connection and the theoretical of combination is the same. So
Well, the two programs should give you exactly the same thing until we get to the nonlinear part.
Yeah.
So right now,
Yeah, I totally agree.
we need to make sure that we are getting same results.
Yes.
And at this point, Steve's got two different models and he's getting two different results.
Yeah.
I'm hoping that as soon as you get yours in, we can determine what's happening here.
Yeah. I think one possible reason for his error is that when the slab, the mesh, they're not fine enough, so they didn't get a good displacement. When it's become finer and smaller, the result become converged. So I think if he meshed very fine, he gets the final
Well, maybe
result.
he should go in and put another mesh refinement on the slab.
Yeah, yes. If it's very small, like this kind of piece.
I mean,
so,
his results, quite frankly, are not that much different between
Okay.
the two models.
Yeah.
I mean,
yes.
there's some.
Percentage-wise, like 40%, not 30, 40%.
I know, but you got to
Yeah.
remember, you're still at 1 inch versus a half inch. I mean,
Yes.
and let's keep that in perspective.
yep.
I mean, if you have 0.06 and 0.09, it means nothing.
Yeah, it's about that. It's about that range.
Yeah.
Yeah, point
I mean, so-
0.58 and 0.98 or
So
something.
it doesn't mean anything.
Okay.
You know, if it gets. So let's keep it in perspective of what the magnitudes of these values are.
Okay.
But I do think that Feng has an important point, which I didn't bring up, is okay. So maybe it's all in the. Why would that? Maybe refining the slab, because you didn't refine the slab anymore in either model, right? You left
No,
it the same.
and the meshing of the slab is the same for both models.
Okay.
Yeah, I think if he mesh his slab and beam into very very tiny, so it will give the correct result. If more finer, the
Well-
result definitely more
Well,
better.
well
but take more time.
the slab meshing are the same for both models, but for the first one I didn't mesh the columns or the beams at all.
Uh-huh.
The second one I meshed them. I
Yeah.
divided each element into 10 different sub-elements.
So one thing you should do, I'm a little worried here by looking at your slab, the rectangles are quite large. You remember, use 2-to-1 ratios for those, or smaller. Width to length of your
Yeah.
of your.
So
of
you
your solid.
okay? So you think the okay? I see.
Yeah, actually,
I think you need to get finer on your
Okay.
slab mesh for
Yeah,
sure.
yeah, I can do
Okay.
that.
yeah. Actually, I work with Natasha's project, and he said the column, the mesh length shouldn't exceed the like a cross section of this.
That's
this
correct.
beam. So if it's mesh 10 is not enough, so should be very fine. Not there has a criteria, not beyond.
And there may be
cross-section.
nothing more than that. I mean, it might be that when you meshed them, the results change because the slab is behaving differently. In spite of the fact that it's still connected differently, I mean the same, but the load distribution might be different.
Yeah.
I mean, so I think let's start refining that slab.
Okay.
Get it till there's no change in your results.
Okay.
I think you got a point. When there's no change in your results, then you're getting fine enough that we know that we got a good model. Okay.
Okay.
All right. But do check the loads first before you do anything else. Let's see where you are in terms of vertical loads.
Okay.
Something that makes sure that what comes down goes back up in both models if it's the same, and then refine your mesh on your slab.
Okay.
All right. And I think I would do that with the model that doesn't have all the refinement on your beams and columns.
Say it again.
Use the model that doesn't have all the refinement on
Okay.
the beams and columns.
Okay.
Because you're going to have to refine your beams anyway because of having more cross points
Okay.
across that
Okay.
with your slab. All right?
All right.
Anything else for you?
I think everything's good. So actually, I will get very fine mesh and compare with his model, and I will make sure if I mesh twice, the displacement or the movement is not get any change like beyond 2 or 3%. So the model is fine enough. So
All right.
yeah, it's doesn't matter with the mesh and everything is in the like geometry or cross sections area. So
Okay.
yeah.
And Dr. Halsey, I told you before, so you told me to put unit forces or moments in different directions and see how the response of the building. And the model is with respect to different forces in unit forces in different directions. And I told you, I think because of Saint Venant's principle, the force. I mean, the reaction of the force at the unicity of where the force is applied is very large,
Right.
and then it dissipates across,
Right.
far distances.
So what he's talking about is he and I had a meeting earlier today, and we're going to probably put a uniform pressure in a direction
Okay.
at the middle of the slab or
Yeah.
somewhere on that center, and then do it the other direction, and then have a moment which would be basically a pressure distribution to give a couple, and then we'll see what that does. I mean, we may have to reorganize again, but
Okay,
at this
yeah.
point, I'm just trying to get a handle on how this building responds
Okay.
to these loads. Okay.
Yes.
All right. Okay, so in the next 2 days, I'm going to ask you guys to take and put that film onto onto your hard drive.
Can we do that? Okay.
Yeah, you just copy it.
Oh, okay.
It's digital.
Yeah.
There's a little card in there that you just take
Oh, I
out
see.
and put it in, and then copy it in,
Yeah.
and then I'd like to send that to our funder and let them take a look at it.
Okay.
Okay.
If it can be emailed, if it can't, then we'll need to send it by a CD or something.
Okay.
All right. So
And what about our daily reports? You want to send that to them too?
we can, yeah, sure. You
I
bet.
mean, yeah, no,
Yeah.
I don't mind. Yeah, wait.
And I'll symbol that,
Mhm.
okay, or you guys can.
Yeah,
somehow.
sure.
All right. Anyway, so go ahead and I guess continue on, and then I will, not tomorrow, but Wednesday, let's plan on making a copy of this.
Okay.
film,
Okay.
So they
Okay.
can take a look at it. Okay?
Okay.
All right? Thank you.
Right.
All right.